Hey folks, back. This is the second time I'm doing this video because I did the whole thing and realized I never turned the camera on. So anyways, back to the task. This example here I've changed up from the last video. It is a 24 volt DC circuit with 3 resistors in series, and all the resistors are a different resistor value, okay? So our voltage drops are going to be different. They're not going to be like the last one that were both exactly the same. If you notice right there, I went ahead and did my Ohm's law circle there to help for my memory jogging. Now for me, I know this stuff, I don't have to think about it. But for you guys, when you first start off using this, get used to putting that on there. It'll get to be a point where it's just matter of fact, and that's what you want is in the field of electricity, whether it's electronics or electrician. Getting where you know Ohm's law like the back of your hand is going to be a key thing for you to be able to do quick figures and that while you're doing your job out there. So remember, in our matrix here, we create that. First thing we want to do is write down our information that we know. So we know our voltage, circuit voltage is 24 volts. Resistor 1 is 5 ohms. Resistor 2 is 10 ohms, and resistor 3 is 25 ohms. Okay, so the next task is what is the rules for figuring out our voltage resistance, and that is to just simply add those up. Okay, so 25 and 5 is 30, plus 10 is 40 ohms. Okay, so remember, this is our total for our resistance. And next thing is, if you give me any 2 pieces of information in an electrical circuit of the 4, I don't have power up here, but if you give me any of the two of the 4, I can figure out all of this information. So here we have enough information. And what we're going to do is we need to know the current. So we take our volts and we divide it by our resistance. So 24 divided by 40 gives us 0.6 amps. Okay, so also as you guys get more used to this, it would be 600 milliamps is what you would refer to it, but here we're just going to keep it simple and just do 0.6. It's 1/6 of an amp. Okay, so rule in here with series circuit, our voltage stays the same, or excuse me, our voltage is what changes on each one of our part of our circuit, but our current stays the same throughout. So we're going to go ahead and just bring our current down automatically. So 0.6 amps, 0.6 amps, and 0.6 amps. Okay, so now we have enough information to figure out our voltage drops coming across here. So 0.6 times 5 is going to give us 3 volts. Okay, 0.6 times 10 is going to give us 6 volts, and 0.6 times 25 is going to give us 15 volts. Okay, now the next question is, do all of these add up to this right here? And the answer is yes. Okay, 15 plus 6 is 21, plus 3 is 24 volts. And again, folks, your numbers may not come out exactly on 24. It may be 23.93 or something like that. And that's depending on your calculator, how you're doing your numbers on your decimals in that. All right, so don't sweat that. But if you get close, to 23 and some change, you're fine. If you get 16 and some change, you've done something incorrect. Okay, you need to check your work. Now remember on this, the numbers that you come up with are suspect numbers. Take that number and use it in Ohm's law with one of your given numbers to check it against your other given number. So this one here, like last time, that was our suspect number. And we can take the 24 divided by 0.6, and that should come up with 40. We can take the 0.6 times 40 and come up with 24. But we can work that a couple of different ways to make sure that your number is what you're supposed to have. Okay. And the same thing with all of the rest of this stuff here. If you have any questions, please make a comment. I'm going to do one more video on this, on an example for series circuit, and then the next one I'll make after that will be for our parallel circuits. Those are a little bit more complicated, but not something that you won't be able to do. Okay, be safe out there, and I'll see you next time.